Welcome back to Tier44 Technologies. Today this video is going to talk about an add-on to EM8 available in the ServiceNow store. This software is part of Tier44's Global Energy Intelligence add-on for EM8 and enables monitoring capabilities that can be used in your data center, such as monitoring room temperatures, amperage drawn busways, and power states of servers. Everything I described today is completely customizable to meet the needs of your company. We provide an API and robust example of how to use it. Let's take a look at the properties first. There shouldn't be any big changes necessary, but there are minor ones you may want to change. You can choose a specific group you want to assign monitoring processes in the event human remediation is needed. The default is IT services. You can turn on debugging, change the selection criteria for mid-servers, as well as the repeated error count before notification, or process cycle time, which is the wait time between the end of one monitoring process and the beginning of the next. Or leave everything how it is. These are all currently the default settings. Next, in order to effectively use this add-on, you need to know what you want to monitor and how to access the data. Once you know, you can request a process by going to the ServiceNow service catalog to order Tier44 monitoring. We have 6 different elements to choose from, mix, and match. Ping sends an ICOMP packet to a machine's IP address to see if it is alive. After typing in an IP address, select a mid-server. The Any Available setting will choose a mid-server based on the search setting in the properties, the Tier44 monitoring ping capability, and the mid-server's configured IP ranges. Or you can choose a specific mid-server that has the Tier44 monitoring ping capability, but the options in the selection drop-down do not take IP range settings into account. It is up to you to choose a mid-server that can reach the target machine. Tier44 monitoring comes as a completely blank slate, so it is up to you to set up the mid-servers and configure their capabilities and IP ranges. We can take a look at that table here with examples of a few we have. A mid-server's physical ability to connect to another machine is determined by firewall and network setup by IT. Next is port scan. Port scan is a slightly more powerful version of ping. Again, you give an IP address and then ports you want to scan or connect to. You can specify any TCP port or comma-separated list of ports, like port 80 for HTTP, 443 for HTTPS, or 25 for email. There is a timeout of 5,000 milliseconds or 5 seconds. If no connection can be made within that timeout period, the element will then report a failure. Choosing a mid-server acts the same way as choosing one with ping, but uses the Tier44 monitoring port scan capability. Below that, we have web status check. You will enter a URL and, if necessary, a username and password. The password is masked and encrypted when it is transmitted to the mid-server. Web status checks connects to the specified URL and verifies that the HTTP result code is in the 200 range. When selecting a mid-server, it is assumed that any mid-server with the Tier44 monitoring web status capability can reach any URL. Web content check is very similar to web status check, but adds a feature to examine the content of the web page requested. The content field is a case-sensitive, regular expression that can handle plain text as well as popular meta expressions such as groupings and wildcards. Then selecting a mid-server works the same way, keeping the same limitations in mind. The next element is simple Modbus. Modbus is an old RS-485 serial protocol for accessing data in things like mains power meters. Modbus has been modernized to make use of the TCP IP networks to connect to those large power meters. If you wish to use Modbus and your power meter does not support Modbus TCP, you will need a Modbus TCP to RS-485 gateway. Enter the IP address of the power meter, its unit ID, register set, and register ID. Unit and register information can be found in the meter's documentation. Select a comparison such as less than, greater than, or equal to, and the expected value stored register. This example only holds 16-bit single register integers. However, our API can work with multi-register values, IEEE, floating point values, and ASCII character data as well. Lastly, we have simple Snmp, which is a standard network management protocol used by servers, power strips, and many other devices. Enter the IP address and community string, which is treated as a password, and the numeric OID or object identifier of the value you want to retrieve. Comparison and expected value work the same as above. These are all the different elements you can choose in your process request. Choose all or just some, it is up to you. Once you submit the request, an admin or supervisor within your organization will approve it, and then a service catalog task will be created. We do not place a limit on the number of monitoring processes that can be created, and the elements in and out of the box request form are an example. You are free to create your own catalog items and expand our API. Let's take a look at the monitoring dashboard. This is an overview of the active processes. If any of the one element within a process fails, the process as a whole is considered failed and will turn red. Because of the nature of the internet, sometimes false negative results occur. For this reason, there is a warning period. A process that returns an error is considered a warning until the configured retry count is exceeded. Retries are performed much quicker than the normal cycle time. When a process turns red, it will be escalated to a human group such as IT services, where the errors can be addressed. If the problem clears itself before the associated task is assigned to a specific technician, Tier44's digital employee will pull the task back and return the process to the green success state. The dashboard will show when a process's tasks has been escalated and assigned to a technician. Once the problem has been fixed, the technician simply assigns the task back to the Tier44 digital employees group in the open state and automation will resume. We can take a look at the temperature that is being monitored at our San Antonio location. By clicking into the task, you can see the elements that were selected and the result of the process. The cycle time is 5 minutes, so this process will sleep for 5 minutes between each run. If anything is wrong, it will show in the dashboard. This task is Tier44 digital employees, which means it is running under automation. Digital employees smooth out intermittent glitches that can sometimes clear on their own when nothing is actually wrong. Processes can also be updated on the fly, and the changes are reflected in the dashboard the next time it runs and completes. Whether you just want to change the machine you are monitoring or add another element, you can just by changing the selections and clicking Update. The dashboard is driven by the monitoring elements table. Each process is represented by 2 or more records in this table, 1 monitoring process record and 1 or more element records. We recommend using the dashboard to access this table if necessary. While the configuration and results are stored in these records, they are really for coordination. Changing values here will not change the way processes are run. After submitting the service catalog form, a flow is started to create a monitoring task that is automatically assigned to the digital employees group. For every type of task you want to automate, you create a flow designer flow that is triggered on the creation of such a task for the digital employees group. That flow will put individual actions into the ECC queue for mid-servers to execute, and put the result back into the monitoring elements table. When the flow has launched all actions and is complete, the task will be closed. To restart the loop, an event is automatically created to reopen the task in X number of minutes. If an error occurs in any of the actions, the return processing unit will reassign the task to a group of people to take appropriate actions. When someone has fixed the issue, they mark the task complete and reassign it back to the digital employees for further monitoring. A self-updated dashboard is provided as part of the application to track the status of all monitoring processes. This concludes our video on the Global Energy Intelligence Monitoring add-on to Tier44 for ServiceNow. Everything is configurable and completely customizable to meet the monitoring needs in your data center. We provide the ability to monitor devices using mid-servers within your organization via ServiceNow. If you would like to try it, be sure to visit the ServiceNow store for a free trial today. Thanks for watching and stay tuned for more tutorials and enhancements to Tier44's Global Energy Intelligence.